Hey guys, and welcome to another tutorial by HG. Recently I created a new intro for myself, and of course you can do it. I created this part of this intro with plugin, with really PF source and a little compositing. So I thought myself maybe it's useful to share this and how I created this. So this tutorial is about this. Actually we will work with data operators and a little bit with PF source. Let's before beginning let me show you the finished version so you have a view what we want to create. This is what we want to create. We have some particles on the ground and they will rise up and you see it's like a vacuum cleaner because the dust or the particle or whatever you call them, they're trying to come to the center. Actually they're trying to come to the point of this pointer, and this pointer is rotating around. So you can see that kind of this point here is where the particles get up and try to stick on this HG text. This is what we want to create, and after that I will show you how I did it in After Effects. But the main part is in particle flow, and as you can see there is just one thing that we have to discover, and it will be this data operator data text. So in this tutorial we wanna go through all this step by step, and we'll explain to you exactly how we will achieve this effect. I hope you will stay by me. It will be a lot of fun, I promise, and a lot of new things that you'll learn. So for the intro start, we'll begin with this scene. It's nothing here except two secrets that I want to explain to you why the reason. Okay, I select the first secret that is inside and go to here and apply edit part. So we have a surface just for this, and also we go here and in particle system we create a field source. After we create a field source, we go to the particle view. Here in particle view we will change some of this. For example, interpolation, half frame, and viewport 100. Okay, and layout stop and view, for example 1000 10,000 for begin, and get rid of speed, rotation, shape, and let's have display as dot. Okay, so instead of normal position we want to change it to object position, and we go here and say this will be our emitter. So you can see right now that we have some particle here, but they do nothing because there is mostly nothing. Okay, the next step will be to create something that move. How to do it? Okay, before I do this, I will create 2 points or 2 half. This is one, and copy. This is the second one, and I link the second one to the first one, and I tell you right now why I am doing this. Okay, right now I have 2 points. or to have. So the reason what I'm doing this, I want the particle to rotate around, okay, let's say around the center or around the point. So for rotating the particle around the point, what you need is an axis. An axis is a vector, and we can have a vector when we have 2 points. From 2 points, you can get a vector. So this will be our vector, which the particle will rotate around it. That is why we have right now 2 points. We created 2 points. I bring this here in the middle, exactly in the middle. And so while now this is my axis, my rotation axis. What we try to do is to mimic the force vortex. The force vortex is exactly like this, what we want to create, but we want to write it by our own, and we want to discover, we want to go into it and do some special trick. So this will be our axis that the particle will rotate around. So that is why we created this. The next step, I press 6 here and I go here to my depot, and what we need here is data test. Okay. Enable auto update and open. I minimize this. And right now we want to begin to create our data operator. The first thing that we try to do is select object, and the object will be, I press H so I can see the viewpoint 1. Okay. Another one, we need another one, and once we can press H, this time point 2, and we need object parameter of objects, and we say object pivot, and once again select object pivot. So I have the pivot position of this point, I have also the position of this point. Okay, I have the position of both these points. So the next position that we want to have is the current particle, because this data operator will execute in each frame for each particle individually. So each time that the processor will go through this data test, it will calculate the position of each of these particle individually. So the third point that we need to have is the position of the particle, the current particle. For this, I bring an input standard, and I let it here in position vector. So I have right now 3 points. For example, we say here we have a particle. This is the particle, this is 1 point, and this is 1. This will be our axis. So how to create this axis? I create a function and say subtract point 2 from point 1. So what we have right now here is this axis. Okay, we have 2 points, we subtract and get the axis, and we want to have another axis here. So how to get the other axis? So we have here this point and the particle's positions exactly the same. We say subtract first point from the current position. Okay. Right now we have two vectors. So a vector here, a vector here. So if we right now apply function, and if we apply vector product or cross product, what will we have in cross product? We will give in cross product in mathematics, we will give two vectors and it will give us a third vector which is perpendicular to both of these vectors. So if I give this right now, this will be the vector or the direction of the rotate, right? This will be the direction that the particle has to rotate around the axis. So this is from okay. Let's go further and let's just create an output standard, and we will say in output standard speed and vector, and just let's see what we have. So it will disappear very soon, so you can see nothing. This is because the speed it's too high. So what we have to do is reduce the speed. Okay, how to do this? We create a function, turn off the second operator, and we say normalize and factor 0.001. Okay, this will be a little amount, so the particle has to rotate. Let me just hide the circle and see the result what we get. So the particles are rotating, but they are staying on their circle sides. They cannot mirror to the point, just rotating around the point. Let me here do something, because this the second one, I mean the vector which from the point to the particle's position, we need this more than one time. Instead of creating this, just let me delete here and create an output with, and let me name this output new particle distance. Vector. So we created here right now, and here. So because we need this information more than one time, so instead of doing it every time from here, it's better to manage. So right now I did this, but here we need this information right now. So we go here and input custom, and if we input custom in the channel, you see this is what we created right now, and we can bring this here and connect this here. But there will be something very important. The important thing is that the order of execution. Let's do this. Right now, if we press this, you will see the order of execution. You see the first step will be speed vector, which is 1. The first thing that should be calculated is the output of our particle. So we select it and say priority order to 1 and execution order to 1. And we select our speed and say not only the priority order, but execution order to 2 and priority to 1. It means that each time that the in the process, first this will be calculated. After this is calculated, the execution order. Once again, all this data will be calculated, but for the other reasons, and not just the period. So we created this until now. The next step is you see that the particles are rotating but really coming near. So we have this distance from point to each particle. We have just to shorten this distance so they can come near. So how to do it? We have the distance just completed make sure that the instance. And where is the instance? We have here the instance, okay? So very easy. We can create here after the normalization, we create another function and we will say vector class. Connect this and connect this. But as we saw in here, the vector is too big, so before we do this, we do need normalization here also. Okay? 0.00 and get normalized and connect this to here. So right now we have if I scrub the timeline, you can see that not only the particles will rotate around this point, but also they are coming near to the point, because we are telling the particle that in each frame the vector will get a plus of a little bit of the distance that we have here. Okay, if we bring this number higher, 1, you can see that they will come very soon to the point. So it's up to you to define the speed, how fast they can come to the point. And you can see points. And the point is this, because right now these 2 points are in the same perpendicular, they are coming to the point. But if I, for example, move this, let's see what will happen. You see, the direction of the particle will change. This is what I mean. Okay, but so that's so far so good. The next point is create a filter. The next point will be create a filter. For example, we have a circle here and we want to have the circle as a filter. For example, we say just the particles that are inside this circle will affect it to this. So for creating this, we once again go here and we create an object parameters. And here in object parameters, we press H and say circle 1. And what we need from circle 1 is the radius. So we get the radius, and we have also our output and input custom, which will be the vector instance, and we bring a function and turn off the second operation and length. So right now we have a length of from the point to the particle, to the current particle. So we want to say if the length of the particle is smaller than the radius, so it affects it, and if not, do nothing. So for this, what we want to create, we create a condition and we select it, and instead of having here just a number, we will press R2 so we can give this parameter and output parameter, and I connect this to here, and you will see that right now we have conditions that say if the radius is greater and in this case we have to say less. If the radius is less than this, or if the length is less than the radius, so this will be true to affect. So I connect this here. Then I can see the result. Oh, sorry. greater than So you can see that just the particles that are inside the circle will get affected. If I increase this, so that is wonderful. Okay, just for management, I select this here and go to group and make a group, and for example, color remain figure. I have to close this. That's for the reason of management. The next point that we want to do is you can see that all the particles get affected same force, which is I think not good, because the particles that are near to the axis must affect it more, and the particles that are far away so less. So for this we should create a fall-off effect. So the fall-off effect will be as easy as saying very easy. I create another input cursor. You see, we need it more than one time. That was a good idea to have that cursor. And after this, we bring a function, turn off the second operation. We want to have the length, so get the length. And after this, of course, we need the object. So we need the object parameters. Once again, press H, equal 1, and what we want to have is the radius. So we have both of these, and we bring the function, and in this function we say just instead of vector we bring it to real and say divide. Divide this value, this value. So what we did right now, for example, this value is 100 and the radius is 120. So 100 divide 120. And I create a scalar. So I let it to be 1, and create another function and select that subtraction, not vector but real, 1 from this. So what this function will do for me is will give me a number between 0 and 10 and 1. These particles that are here around the sequence, they have the value of 0. But if you come near, you get the value of 1. If I didn't do this it should be subtract, sorry. If I didn't do this subtract, the value of here would be 0, and here we get the 1. If we came near to the sequence, we get the bigger result. But when I do the result minus 1, we have the inverted result, which will be particles that are near to the point, they have the value of 0 or get to the 0 value, and the particles that are around it in the circle, they have a higher value. So, and after I did this, I create another function, and the first operand should be vector, but the second one should be real. So I connect this as the second operand and our vector final output vector here, and I connect this to my speed. So just let's see what we have the result here right now, and we can see that we get it. The particles that are near to that point have more speed, so we have a fall. But you can say that is enough for you right now, but if you want, you can add another thing, and this will be the gamma, which right now the gamma is linear, which the interpolation, the fall of interpolation is linear. So you can very easily have a gamma by yourself which will be to create another function, and this function of course will be real, and create another scalar, and just instead of connecting here, put this 2 here, and select this here, and we will say here power. This will be our gamma. For example, if I select the value of 2, I will have a curve of affecting the particles. So this will be our follow. I select all this, and once again group and go here and rename it. It will be our follow. Okay, I can even close this. So right now I have my first vector, my second vector. I normalize my vector. I make the cross product here. I normalized it, and after that I use once again the first vector to have the value to bring the particles near to the point, and I have my follow here, and also I have my filter here. So that's pretty it. There are just a lot of just something else we have to add. Okay, we want to add some drag force. We can use the drag force from here, or we can write it by ourselves. And let me explain it to you what I mean with this. For example, here, if I bring a speed, here, and you will see that they are falling. All the particles are falling because this is speed, and I turned off my test. So I select my data test, I open it, and instead of all this stuff that I did, I bring this here, disconnect it from here, disconnect it from here, and create an input standard, which will be my speed, and I use my vector as speed, and I connect this here. So what we have here right now, it's actually we have nothing. We get the input speed and we get it out, so they will do nothing. So but just see what I want to do here right now. I bring a function here, and in this function I turn off the second operator, and instead of this I select identity. So I connect it to here and connect it to the output. Because right now the identity is to 1, it will do nothing. But what will happen if I, for example, change the value, for example, to 0.7? Just see the result. They are coming down, and after a while they are stopping moving. Why it's happening? Because in each frame, each particle that will be calculated here, get the speed that they had, and multiplied by the 0.7, and so each time we will have a lower speed value. So if we, for example, had this value instead of 0.7, for example, say 0.9, you have a less drag. So this is actually how you can create your own drag effect. It's so simple. Just to know how it works, and it's all. So instead of using this, which is not in our use, I bring this here, and what I want to do here, I create, yes, it will be out now. For example, I say 0.8. So here we will have our thing. Okay, the last thing that I want to do here, that is very, very important, is I want to have the speed of the last frame, so I can add the speed so they get faster and faster in each frame. So to do this, I create an input standard, bring back to 0 so it's easier to work. Input standard, and I say I need the speed and I need the vector, and I bring the function and before here, delete here, and I make an addition between the speed that I had in the last frame and this is the result here. Okay, so this is my last frame speed, this is my damping value, this is my far filter, bottom, and other stuff. So just see the result. Oh, we have to, of course, delete here the speed because we don't need it. And see the result. So if I just, for example, bring this a little higher, we can see a beautiful effect that we have created right now. And you can do pretty much beautiful stuff with it. Okay, let's bring it back. So we created this until here, and I think the last thing that we have to do is to pass this data to the next event, because we use data test, so we need the test to go to the next event. So how to do this? Okay, we create once again an input custom, which will be my particle distance. I bring a function, turn this off and say length. So I have my length here. After I get my length here, I bring scalar as my trigger, and for example I say 20, and I bring a condition and I say if the length is less than 20, go to the next event. This is it. We will have a problem here. Let's see the problem. You see all the particles are right now in the next event. But I said just if it's less than this. You see, because the color, this is dark green and this is another color. So we have something weird here. But why is that so? Because of the order of execution. So the first thing that it gets executed is output new particle distance. And when I created this, by default it will have the execution order of 1 and the period of 2. But I want to have this calculated and the execution order of 2 and the period of 2. So first calculate my distance, then my speed, and after that my output. So right now, if you see, the result is right now correct. Yes. So I select all this stuff, make a group, and rename it. And I name it path to next event. So we are finished until now. The next event will to bring my text. I have my text here and say find my target. So from here other stuff are easy. Bring a find target here. Say my target will be object and add it here and make it follow target animation, and the speed should be not too much. I make a speed of 100 with 10 variation, but when they are coming towards, you see, when they are coming towards my text, they have to go to the next event, which will be, they should stop. So I bring an speed for say 0. This is my next event. And when they are there, so after they have 0 speed, I should use an let's see look bound. You see here it's coming up. I change it from tick to dots, so it's more easier to see. They are coming up and they are get stick to my HG, so that's pretty. The next thing that I want to do, instead of having my point here, just let me hide this and hide my helix. I have here a helix, and I select my point and I say animation constraint, path constraint to my helix, and I bring it from here to 50. So they are right, it's right now rotating around here, and I select and hide by name my model. I make this bigger. This is circle which defines which area I want all the particles to affect at the same time, so I make it bigger. I can hide my fair circle and just see the result. I think that we have to change the color. This dark green is not very easy to see. Okay, I think I have a camera and see it here. So just let's see what we have until now, and that is it. You see the particles are rotating around this axis and are going to the next event, and all the other particles get affected and try to come near to the first point, like a vacuum cleaner. That is the cool thing in this effect. Yeah, very, very beautiful. So after this, for example, at frame 70, I want to blow up the text, so reveal the real text that is behind it, not just a particle one. So for this, I create an H test, and we will say when we reach here, the absolute age, of course, absolute age of 70, and with 0 variation, go to the next event, and in the next event we have a speed which use an random horizontal. Okay, and you see after frame 70 they are blowing up, but I don't like the way that it's blowing up. It's very simple, so just add a random walk, okay, here, and we will have a much nicer result. Let's see. Wow, this is what we are searching for. But I think the speed is still too much. 100 pretty better. 300 is too much. Okay, they are coming here and they are blowing. Okay, and after a while, for example, H test 30, H test 30, H test. But I want to say, even H of 30 with 50 variation, delete. What is my delete? Delete. Okay. So that is the whole effect that we have. Coming, shaping this HG and get exploding and get deleted. So that was all the stuff. Just for let me see my final touch here. What I did here in the final step, I did a couple of things that I have to explain. I use Krakatoa for rendering, so therefore I have here more than, okay, I changed it here, but it was 2 million particle here, so I needed too much particle for having a nicer result, and you can even have higher value. And I render it with Krakatoa, and also what I did, I create another version of it, but not with 2 million particles, and just with let it load first. Okay. Okay. I have here the same thing, just my computer is a little bit slow for all this stuff, and I should be careful when I want to create something big like this. Okay, for my film effects, I reduced the number to 10,000 because my computer couldn't handle it, of course. And you don't need so much particles for creating film effects, of course. And I created a container, and also to take some time to update it. Okay, I have a film effects container, and let's see the parameters that I did. I have my object. This is my particle emitter. I have zero amount of fuel, and temperature also zero, a little bit 0.5, 0.1 smoke, and in the simulation maximum alteration 50, a little bit turbulence, not too much, touring scale, part of details 5, no fuel simulation and smoke simulation, and I didn't change all this stuff at all. So, and after that I also rendered on, or also I turned on here smoke, cast shadow, and in the render I also turned illumination. I created 3 spots here, and I turned on the multiple scattering. So we set this, don't save, yes, and just okay. What we have here, this is my After Effects project, and just explain very short what I did, because this is my particle render. I bring a new separate. You see here that because I had not too much particle, just 2 million, there are a lot of free space here, and I don't like the effect that it's here. But here I think it's good now. So what I created, I also created, I have right now here my smoke, and I put the smoke on top of it. And you see both of this, I have a very beautiful effect here. You see, this is the smoke that I have, make it touch, but I like it. It's not more for a simple particle. But I didn't like the way that it's here in the bottom, so what I did was this. I created, this is what I did. Instead, see here the effect is very beautiful. Of course, I did a curve. After that, I made a real smart motion blur plugin. I have it for making some motion blur, and I I applied an CC vector flare, which with the direction fading, which give you the feeling as if it's like fluid and not something. So I like the result right now. Okay, see without and with. So with this effect, CC vector blur, you have not the feeling that it's something separate particles from the ground. And but I did like it until here, because when the particle trying to form the shape, the G shape, I like the way that the particle works. So I made I copied this layer and made just two masks. So until here we have the effect of the vector blur, but from here with the feather we didn't have it anymore. And I also have a background image and I have an HG text, which is a 3D text, and I brought it here after exploding the text itself. And all the other stuff is pretty easy, just have some glow when they are trying to explode here, and some glow here, and an optical flare, and CC, and maybe I'm gonna look for let's see here. I have a vignette here and a operation. So just have to see the other difference between red and green and blue channels. So that's pretty much it. I hope you enjoyed this tutorial and you learned something. If you have something in your mind or a question, feel free to ask me or email me. And of course, if you liked my tutorial, don't forget to